So in this video, we're going to move on to the next topic, and that's regression analysis. And that's just the process to determine the model for the data set that you are given. Now, the model we're going to be working with is a linear model. In other words, we're going to be using a straight line to best represent our data set. So here are a couple of scatter plots. So once again, scatter plots are just a whole bunch of data points, each point being an XY pair, right? And you can visualize that, we can see a trend taking place here as well. Here's a trend going through there. There's a line. There's a line going through this data set. And from this, we can speculate that, the R value is going to be positive. R value is positive. In this case, R value is negative, negative correlation. So what we're going to do is we're going to try to figure out what is the equation of the line of best fit through that data set. Okay, that's what we're trying to accomplish here. So a couple of definitions. The regression line is the line that best fits the data set. The regression equation is the equation of that line. Now, in your high school math and algebra, you may remember that we can express a line using the equation y is equal to mx plus b, where m is your slope and b is your y-intercept. So if you were to extend this line where it crosses the y-axis, that is your y-intercept. So if we extend this, this is where it would cross, and likewise, if we extended that line, this is where the y-intercept would be. Now, if there seems to be a relationship between the two variables, then a linear equation can be determined. And now, how do we know if there's a relationship between the two variables? This depends on our R value and how strong that R value is. The closer is the 1 or minus 1, we know that the stronger the relationship is between our x and y values. Now, with that said, how do we determine the best line of fit? So here is a handful of data points, and we use what's called the least square criterion to find the line of best fit. So there's a line that's put in among the data points, and each data point to the actual model line has a bit of error. And if you square that error, and visually it looks like this, and we take each of these values and square it, turn it into a square, right? So on and so forth. If we can take the line and allow it to move so that as the line moves, these squares change shape and either get larger or smaller depending on how the line pivots. So ultimately, we want it to set up so that the line gives us the smallest possible areas for each of these squares. Now, mathematically, it's all taken care of in the formula, but that is really what is happening behind the scenes. Okay, so you don't have to actually do any of the pivoting of the line or what have you. The formula just works out that that is what's happening. As this line moves, for instance, if this moves up a little bit, this square gets smaller, but this square would actually increase depending on where it pivots as well. So it is a combination of all those different squares having the smallest possible area. So that's the least square criterion. All right, so let's take a look at our first example. And so we have average daily temperature and average monthly precipitation. So once again, I'd ask, what is the dependent and independent variables based on this information? And I would say that our temperature is free to change, but the precipitation depends on our daily temperature. All right, so our independent variable is temperature and dependent is precipitation. Now, I want you to determine linear regression equation, but in order for us to do that, to use the formula, we're going to fill in this chart once again. Okay, so it's the x, y, x squared, y squared, and xy values. So we're going to put these into our table, and let me bring this out a little bit so I can see all the numbers. And I'm going to ask you pause the video and fill in the table and compare notes. So I got the following values, and I'm going to find the totals. So this is my table all complete. Okay, so once again, in a test situation, I might ask you to do this long form, and you should know how to interpret what the different columns represent and what the sum of those columns are. Now, to find the slope of our equation, instead of, as I'd mentioned, y is equal to mx plus b, we're going to call m the slope, a, and b is going to be the same. It's going to be the y-intercept. Now, in order for us to find the slope, we're going to use this formula. And so let's put this all together. In this case, n is the number of data points we have. We have 1, 2, 3, 4, 5, 6, 7, 8 data points, or data pairs. And we're going to multiply that by 524.5. And then from that, we're going to subtract the sum of the x's times the sum of the y's. Okay, and that's all going to be over n equal 8 data pairs times the sum of the x quantity squared, 5450, minus the sum of the x's, 206 squared, quantity squared. So this gives us the following. Now, just to save time, I did the full calculation. And once again, if I ask you to use the formula, I do expect you to show me the detail. And your calculator will actually have this value stored in there when you enter your data, but I do expect the detail. So here's our slope. And likewise, I'm going to ask you to calculate the y-intercept. Now you'll notice that the formula does make use of this value here. So you need to make sure that this is correct in order for you to find the y-intercept. Once again, pause the video, see what you come up with, and then we'll compare notes. And I have the following. So I have the following for the y-intercept. So to answer the question, what is the regression equation? We have the following. Y prime is equal to the slope times the x value, x prime, minus 4.33161512. So there's the equation of the line of best fit through our data points. Next, what we're going to do is we're going to predict the average precipitation for an average daily temperature of 28 degrees Celsius. So what does that mean? Well, here's our regression line. And what we're going to do, or our regression equation, sorry, and let me just put a little, let me get rid of some of the stuff here. And what we're going to do is we're going to insert into our equation the value 28 for x, and that's going to be the predicted value for y. So we substitute this into our equation. And when we do the math, we get the following. And there we go. So we expect then, when the temperature is 28 degrees Celsius, the average precipitation is going to be 2.9 centimeters per month. Now, I just realized that I use centimeters, 2.9 units, because the average precipitation wasn't specified, so it's going to be 2.9 units, whatever those units happen to be. I'm assuming that they're centimeters. It could be inches, so just make sure that you use the proper units to answer the question. Now, with that said, in the next video, I'm going to show you how we can do all of this using our calculator. Okay, but I think it's important that we know how to interpret the formulas and how to piece together all the different parts. With that said, I'll see you on the next video.